1, angles and radian measure. You'll be able to identify positive and negative angles, identify coterminal angles, convert between decimal degree and degree minute second angle measurements, find central angle, the radius or the arc length measurement given the other two, and convert between degree and radian measure. And you'll know what a radian measure is, all in preparation for the unit circle. All right, first off, radian and degree measure. In trig, an angle is formed by rotating a ray about its endpoint. Starting side or ray is called the initial side. The angle and the ending position side or ray is called the terminal side. A curved arrow indicates direction. So right here, we have this guy going in this direction. A curved arrow indicates direction counterclockwise is positive. So if we start here and we're going counterclockwise, it's a positive angle. On the other hand, clockwise, this is our initial, and we go to here, and this is our angle. We call it theta. That is a negative angle measure. Theta is a Greek letter. It does not stand for T, it's just theta, and it's what is typically used to indicate angles. Lowercase Greek letters are generally used to denote angles, theta being the most popular. But sometimes when you have multiple angles, you need other variables. Therefore, a lot of times we use alpha, beta, and gamma. Again, these are not A, B, and C, or A, B, and G. It's alpha, beta, and gamma, and then theta. Theta is what we will use the most. An angle is in standard position, has its vertex at the origin of the rectangular coordinate system, and its initial side coincides or is the same as the x-axis. So right here, this is my x-axis, this is my y-axis. That's always the same in a rectangular coordinate system unless otherwise indicated. So our initial side is always the same as the positive x-axis. Then the terminal side is somewhere else. Okay, now this one over here. When the terminal side of an angle lies in the quadrant, then it is said that the angle lies in that quadrant. So this, because this terminal side is over here, this is quadrant 3. This green one, it doesn't matter if it's a positive or a negative angle, the terminal side is still in quadrant 1. And then over here, again, it doesn't matter if we're talking about a positive angle or a negative angle, this is still a quadrant 2 angle. Which quadrant something is in is extremely important. Later on, you're going to find out that's how we determine whether it is a positive or a negative trig function, which can have effects on other parts of equations. Now, the terminal side of an angle may also coincide or lie on the x or the y-axis. If this is the case, then the angle is called a quadrantal angle. Quadrantal, crazy word, just means that the terminal side is on the y-axis, x-axis, or the negative y-axis. It doesn't matter, it's going to be a 90, a 180, a 270, a 360, or keep going around angle. Now, degrees. One way to measure angles is to use degrees. An angle generated by one complete counterclockwise rotation measures 360 degrees. Okay, so notice counterclockwise, we're going this way around, so we go from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4, 360 degrees. On the other hand, if we start at the positive x-axis and we go clockwise, like the green arrow here, we go to quadrant 4, 3, 2, and then 1. That creates a negative 360 degree angle. All angles greater than 0 and less than 90 are in quadrant 1. All angles greater than 90 or less than 180 and less than 180 are quadrant 2. All angles greater than 180 and less than 270 are in quadrant 3. All angles greater than 270 and less than 360 are in quadrant 4. A negative angle simply implies the direction it was rotated. Now, You got to realize that when you go the reverse, 0 to -90 is in quadrant 4. Okay? If one complete rotation is equal to 360 degrees, find the measure of each of the following. Now, realize that when you're going around something, you can actually go around a circle more than once. It's not linear. When you go straight out from a point, you go straight out, you can keep going farther, or you can come back, but you can't loop, but you're not looping around. With a circle, you're looping around. So, if I say that something is 2/3 counterclockwise, CC is counterclockwise. Well, first thing you have to know is that 2/3 means it's positive. So I have a positive angle. Counterclockwise is positive. And then it's 2/3 of 360 degrees. Well, the word of means multiply. So we would do 2/3 times 360 degrees. Now, if you've got your calculator, great. Multiply 2 times 360, divide by 3. If you don't, which oftentimes you won't, realize that 360 divided by 3 is 120, and then you multiply by 2, and you have your 240 degrees. Okay? Now, we have 1/2 clockwise rotation. That's 1/2 clockwise. Well, clockwise tells me it's going to be negative. And then it's 1/2 of 360 degrees. So negative 1/2 times 360 degrees is negative 180 degrees. 2/3 counterclockwise rotation. Again, please, you've got to be able to do these things without a calculator. Much of this course, I'll ask you to do things without a calculator. And we're going to keep the numbers small. So the numbers aren't the issue. It's, do you know the process? So, counterclockwise. What does counterclockwise mean? Positive. 2/3. Oh, you know what? I don't want to multiply something by 2/3. I want to make that an improper fraction. So 2 times 3 is 6, plus 1 is 7/3 of 360 degrees. Again, just change those proper fractions into improper, or those mixed numbers into improper fractions. Now again, the nice thing is we did this in thirds. So 3 will go into 360 120 times. Now you can multiply that by 7. Okay, 7 times 0 is 0. 7 times 2, or 7 times 20, you get 14. And then 7 plus 1 is 840 degrees. This simply tells me that I'm going to go around. I'm going to start here. I'm going to go all the way around once. And then I'm going to go around. Whoops. Let me erase this so you can sort of see better. Okay. Got that? I'm going to go around once. Then I'm going to go around twice. And then I'm going to go 1/3 of the way around. Okay? So 840 degrees. 7/6 clockwise. This is already as an improper fraction. Clockwise tells me it's negative. So negative 7/6 times 360. Again, notice, if I'm giving you this to do without a calculator, I'm simply going to give you nice numbers. 6 will go into 360 60 times. You should be able to do that division in your head. Negative 7 times 60 is negative 420 degrees. And that should make sense. Negative 420 says I've gone around more than once. 7/6 is more than 1. All right? So clockwise, positive direction, or counterclockwise, positive direction. Clockwise, negative direction. Now, degrees can be divided into smaller units. A degree seems awfully small when we look at it, but if you go far enough out, if you start talking about going out to space or far distances, degrees become like from the center of the earth to the surface of the earth. It's a long ways. And 1 degree, measured in latitude and longitude, is pretty significant. As a matter of fact, hang on, I'm going to pause this for a moment and show you something. Okay, a degree in latitude, because our Earth, we go from the center of the Earth to the surface of the Earth. Each degree of latitude is approximately 69 miles or 111 kilometers apart. The range varies due to the Earth's slightly ellipsoid shape, from 68.7 to 69.4 miles, okay, at the poles. This is convenient because each minute of a degree is approximately 1 nautical mile, okay? So, we're not going to get into nautical miles and all that kind of stuff, but understand, 1 degree looks so tiny when you do it on your paper, but from the center of the Earth to the Earth's surface, that becomes 69 miles. That's huge. We want to cut 69 miles into smaller pieces. So sometimes we want smaller pieces of an angle. Well, degrees can be divided into smaller parts in 2 ways. First, using minutes and seconds, just like a clock. Think about a clock. Except now, 1 degree, that's equal to our 60 minutes. And it's represented, a minute is represented by a little tick mark. 1 minute, this is no different than your clocks. That's 60 seconds. And it's represented by 2 little tick marks. Now 1 degree, well, 1 degree is made up of 60 minutes times 60 seconds, or 3,600 seconds. The thing here is you can change the word degree to hour. And then you're just working with hours and minutes and seconds. You all know hours and minutes and seconds. You've been doing hours, minutes, and seconds since you were in elementary school. So if you have to, just replace the word degree with hours, and you can do the numbers. Now, this right here, 16 degrees, 40 minutes, 12 seconds. Well, that's exactly how it's read. 16 degrees, 40 minutes, and 12 seconds. Now, the other way to make it smaller, and so I can say that a degree is 1 degree, some number of minutes, and I've broken it up into seconds and realize that each second is a little more than a nautical mile. Okay? And then a mile can still be broken up into smaller pieces, and let's face it, some of us who run, you'd like to break that mile up in smaller pieces. Anyway, using decimals, you can also write a degree as something point something degrees. 10.32 degrees. That doesn't mean 10.5 degrees. That means 10.32. 10 and just under 1/3 of a degree. Now, you've got to be able to convert from decimal degrees to degrees, minutes, seconds. So DD to DMS. Let's look to see how we do that. Right down here. And this is probably one of the things that people struggle with most on tests, because it doesn't seem very hard when I'm going over it. And because it's like hours and minutes and seconds, people are like, oh, I can do this. And then they get on a test. So practice this some. I'm going to convert 16 degrees, 40 minutes, 12 seconds into decimals. Now, first off, think about 40 minutes. Is 40 minutes more than half or less than half of an hour? Well, it's more than half. So I should expect to see this as more than 0.5, right? But it's also not going to change the total number of degrees. I'm still going to have 16 degrees. So if I start doing this, I have 16 degrees. And then I have 40 minutes. Well, 40 minutes is 40 pieces of a whole degree. So I have 40/60ths. And then I have 12 minutes. Well, or 12 seconds, sorry, 12 seconds. If I have 12, that's out of 3,600. Because remember, there's 3,600 seconds in 1 degree. So I've simply taken the minutes and the seconds and change them into their fractional form. Now, without a calculator, boom, that's as far as you can really go. If I want you to do this all the way out, then you just simply take your handy dandy calculator, okay, turn it on, clear it, and then you can simply do 16 plus 40 divided by 60 plus 12 divided by 3,600. And no, you don't need any parentheses because division will be done first and then the addition as per order of operations. So I hit enter and I get 12.6 or 16.67. 16.67 degrees. And that should make sense because 40 minutes, that's 2/3 of an hour. 40 minutes is 2/3 of an hour. 12 more minutes means I've got a little more than 2/3. 16.67 degrees. Makes sense. Now I want to convert 10.32. Well, 0.32 is a little less than 1/3, which means it's going to be a little less than 20 minutes. If you just think about what's 1/3 of an hour, 20 minutes. So now to convert, this becomes a little bit difficult. But I'm just going to go backwards. Notice this, you can go forward and backwards. So over here, I'm still going to have 10 degrees. That's not going to change. And then I have 0.3. Well, that's 3/10, right? And then I have 2/100ths. So I've changed this into my addition problem, just broken it up like that. Except notice that I've got 10 and 100, not 60 and 3,600. I need 60 to be my denominator for my minutes, 3,600 for my seconds. So I'm going to do 10 plus 3/10, and I'm going to multiply this by 6/6. It's a form of 1. And then 2/100ths by 36. All I did was I multiplied each one of my fractions by a form of 1. I want to make it look like this guy so that I can get my minutes and my seconds. Now I have 10 plus 18/60 plus 72/3,600. Not bad, right? You're just going back and forth. Now, you're almost there. I can say that this is 10 minutes, or 10 degrees, 18 minutes, 72 seconds. Okay, think about that. 72 seconds. Ooh. 72 seconds contains minutes. So this, okay, 72 divided by 60 is equal to 1 minute, and then 12 seconds is left over. So now I realize that I have 10 degrees, 19 minutes, and 12 seconds. This part right here, you are simply converting seconds to minutes. And you've done that before. If I gave you some number of seconds, you should be able to convert that to seconds and minutes. That's all there is to going back and forth. Okay, I'm going to stop it here and I'll pick up because I think I'm going to do this in about 3 sections so that you can listen to 15-20 minutes of a lesson at a time as need be. So that'll take care of the first part of this lesson.